My PhD is part of the Olympia project in collaboration with the INEL Prosthetic Center in Vigorso di Budrio, close to Bologna. The objective of the Olympia project is to improve the performance of lower limb prostheses for sprinting and long jumping for the athletes of the Italian national Paralympic team. My research focuses on the socket, which is the element that connects the residual limb of a person with lower limb amputation to their prosthetic foot and possibly prosthetic knee. Prosthetic sockets are made of carbon fiber reinforced plastics and are fabricated at the INEL Prosthetic Center using a hand lamination process. Currently, there are no standards or widely accepted guidelines dedicated to socket construction and mechanical testing. Therefore, their mechanical properties remain unknown, and it is not possible to quantify them in a standardized or unified way. The objective of my research is to determine the minimum expected performance of lower limb prosthetic sockets in terms of mechanical strength and fatigue life, to create a testing system that is able to verify these performances and that is independent of socket design and fabrication process. And finally, to apply this testing system to a variety of different prosthetic sockets in order to dimension and optimize them. Together with my colleagues, we will collect data of sprinting and long jumping of athletes of the national Paralympic team using optoelectronic systems, load cells, and force plates. I will then use this data in order to determine the loading and boundary conditions acting on the socket, and in particular to identify the most critical configurations. I will then use this information in order to dimension a test bench that is able to reproduce the critical configurations acting on the socket. Finally, I will apply this methodology to a series of different prosthetic sockets produced at the INEL Prosthetic Center in order to improve the sockets of the National Paralympic team.